All right, now, oh, one last thing. This is the next example, but before we get started, in the previous example, we had no solution. Remember, we had an inconsistent system, which means no solution, but I didn't write the solution set for that. So in that case, when you have no solution, the way you would write it in set notation would just be with the curly braces for the set with nothing in between them. So this would be the empty set, which means that there's no solution. Okay, so just want to make sure you guys were aware of that. Okay, now, looking at this system, let's solve this system. Now, the thing that I see here, looking at this system of equations, is that I've got x and y here, so why don't we use these two equations to get rid of the z's, and then I'll have my x and y equation, and it'll save us some time and some work. Okay? So what I'm going to do is I'm actually going to let's see, how should I do this? You can multiply this by -4. Let's do that. You could also divide this one by 4, but let's keep everything as integers. So I'm going to multiply the bottom one by -4. Okay, so that's going to give me what? 28x plus 12y minus 16z equals -32. Okay, and so if I add the second one and the third one now, right, what do I get? I'm going to get, right, so if I just, I don't want to cross that out. So anyway, let's just do add down. So this is going to give me 28x, and then I get the 2y and the 12y is going to give me plus 14y, and then the 16 and the minus 16 are going to drop out, and I get what? -10 and -32, which is -42. Okay? Now, I've got this equation and this equation that I can now use to solve. So I'm going to do 2x plus y is equal to -3. I've got 28x plus 14y is equal to -42. So now what I'm going to do is I'm going to multiply the top one by -14. And so now in this case here, I get what? I get -28x minus 14y equals 42. Okay? Now, when I add this to this, I get what? I get 0 plus 0 equals 0. So I get 0 equals 0, which is a true statement, but it doesn't involve any variables, right? So this means that the system is what? Well, there's infinitely many solutions, which means the equations are dependent on each other, which means that at least what? The equations are multiples of each other. Okay? So in other words, that it's dependent, which means that there's an infinite many solutions, right? So anytime you get a true statement like this, now, how do we write the solution? Well, that means there has to be a free variable. And let's say the variable is z, right? You can make any of the variables z, but let's say z is free to be anything. Okay? So that means we could use the, let's solve the other equations in terms of z, right? So let's go back to the original equation. Okay, that's why I didn't want to erase this. Okay, so if we solve everything in terms of z, right, that means what? This equation will give us what? 2y is equal to negative 16z, or excuse me, sorry. Will give us negative 10 minus 16z, and then that means y is equal to negative 5 minus 8z. Okay, so now we got y in terms of z, and now we also want x in terms of z. Okay, so we could take this equation here. Let's go over here. Let's use the first one. We could use the second one, but let's use the first one. So we've got 2x, right, plus y. So let's move the y over. So we're going to go 2x equals negative y minus 3, which means that x is equal to negative 1/2 y minus 3. But now let's substitute in what y is, because again, we want it in terms of z. So then we're going to say x is equal to 1/2 times negative 5 minus 8z minus 3. So now what we're going to do is we're going to distribute the negative. That should be negative, right? Yep. Yeah. So negative 1/2 y minus 3. So then we're going to distribute the negative 1/2. And so this is going to become positive 5/2 plus 4z minus 3. And then again, well, let's simplify this. So we've got 2.5 here, right? 2.5 minus 3 is going to give us 1/2. Negative minus 1/2. So this is going to end up being 4z minus 1/2. All right, so that's x, right? So now we've got x and we've got y. Now we can write our ordered triple. Okay, so our ordered triple is going to be show infinitely many solutions. Okay, because z is going to be free to be any real number. So the way we would write this is it would be the set of all x such that x, hold on a second. Hold on a second. That's not the way I want to write that. It's an ordered triple. The set of all ordered triples, x, y, and z, such that what? X equals 4z minus 1/2, comma, I'm going to write it down here at the next line. Y equals negative 5, or let me do this way, let's write it, negative 8z minus 5, comma, and then z is any real number. And then end like that, okay? So this would be written in set notation. Now if I wanted to write it just as an ordered triple to represent the same thing, you could write it this way. You could write it as, so the x coordinate would be 4z minus 1/2, comma, the y coordinate would just be negative 8z minus 5, and then the third coordinate would just be z. Okay, but again, the difference is this is set notation, right? And this is just showing it as an ordered triple where z is any real number. Okay, that's it. So in this case, there's infinitely many solutions. The equations are dependent. And that's how you would show the solution set in set notation.